Hello and welcome to chemistry again. This is balancing equations, and in this lesson we're going to learn one of the key things of stoichiometry, which is balancing equations to make sure that we have the right number of moles on each side of the equation in order to make sure that we can actually compare them properly. So, we're going to go ahead and go over a couple of pieces of information to start off. First, we're going to go ahead and talk about the laws and the general information and the reason that we have to do it this way. And the reason that we have to do this way is that if we don't balance out an equation, it ends up breaking the law of conservation of mass, which states that the amount of mass that we have on one side of the equation has to equal the amount of mass on another side of the equation. Okay? So if we are not mindful of that and making sure to balance the universe, essentially, is what we're doing, then we're going to have trouble doing our stoichiometry problems in general. Okay? And the law of conservation of mass is essentially that law that states that matter and energy can't be created or destroyed. They can only be transformed from one thing to another. And in the case of chemistry, we usually try and think about it in that atoms can't be destroyed. They just go from one type of compound or element, or a single element, to another type of compound, or they go into their single element form. Okay. In general, we're going to try and balance our elements with the least amount. So we want to try and always have our balancing in lowest common denominators. And then we have to have the same number of atoms in both sides of the equation. So if you notice in this problem here that has hydrogen and oxygen coming to make H2O, we have coefficients in front of the hydrogen atoms, and that multiplies by how many hydrogen atoms there are in that formula. So on the left side, we have 4 hydrogens, and on the right side, we also have 4 hydrogens. On the left side, we have 2 oxygens because there's 2 oxygens in an oxygen molecule. And here, 2 times 1 because there's 1 oxygen in each water, and there's 2 waters. We have 2 oxygens on that side. One thing to note is that while we're balancing, we can modify these coefficients, but we cannot modify those subscripts. Those subscripts are kind of locked in stone right there. Okay. Some additional steps that might be useful is if it's gas, you can go ahead and label it as gas. Solids, liquids, and aqueous are usually written directly after the formula and usually in subscript, and that can help in some cases. So for instance, when we do net ionic equations, we're going to be using this a lot to see what actually changed in a reaction. Okay. Now, let's go ahead and go over the process here. And for step 1, what you're going to do is you're going to start by writing out the equation. Okay. You're going to then, after you write out the equation, you're going to split up the equation into 2 sides. So you're going to have your left side of the equation where you have your reactants and your right side where you have your products. You're going to list all of your elements. Okay, so each type of atom you're going to list, and you're going to number how many you have. And in the beginning it should be easy because here you have 3 carbons, so you put 3, 8 hydrogens, so you put those there, and then you have 2 oxygens. On the right side you have 2 hydrogens, 3 oxygens because you have 1 from the H2O, and here you have 2 from the carbon dioxide, so you have a total of 3. and then 1 carbon. Okay, so that's step 1, just writing the equation out and then splitting it into the 2 sides. All right, step 2 is arranging it so it's going to be easier to balance. And what you're going to do there is you're going to make sure that the elements are lined up with one another. So in the beginning here, we had carbon, hydrogen, oxygen on the left, and on the right, we had hydrogen, oxygen, carbon. Okay, that's going to make it harder to balance because we're going to have to look, diagonally instead of directly across. So we're going to go ahead and change it so that it's directly across. And then I'm also going to go ahead and give you guys a quality of life change to this rule as well. In general, the last 2 that you want to balance in an equation is going to be hydrogen and then oxygen. And the reason for that is because they often end up being the hardest to balance and change the most in an equation. And sometimes what you'll end up seeing is that if you balance them last, it'll just kind of flow smoothly, whereas if you balance them first, you'll have to go back and forth constantly. So just keep that in mind. So we organize them, we put carbon, and then the last 2 we have hydrogen and oxygen. Then what we're going to do is we're going to go ahead and add coefficients, and we're going to add it to our one of the compounds in our first element to try and make it balanced. So in the case of this problem right here, we had carbon that had 3 on the left side, and we had 1 carbon on the right side. So we're going to add a coefficient to try and make the carbon equal. So in this case, we're going to add a coefficient to the carbon dioxide, and we'll add 3 there, which will indicate that we have 3 moles of carbon dioxide that are made in this reaction here. So now that's going to change how many carbons we have, but it's also going to end up changing how many oxygens we have. Okay, so keep in mind that this is going to change how many oxygens that we have as well. Okay, and this oxygen should end up changing now. This will now be 7 oxygens. Okay. Then what you're going to do is you're going to go ahead and add a coefficient to the next one down, which is going to be hydrogen. Okay. So hydrogen, we need to go ahead and transform it from 2 hydrogen to 8. So in order to do that, we'll have to multiply by 4. So we're going to add a 4 to the coefficient in front of the hydrogen here, and that's going to go ahead and change it to 8. Okay. And as we go through, we'll notice that this entire time we've changed the amount of oxygens. Okay, so now we have 4 times 1, which is 4, plus 3 times 2, which is 6. So now we have 10 oxygens on this side. Then we have to add a coefficient on oxygen over here to help us balance it out. So we'd have to figure out, right, what times 2 is going to equal 10. So we'll go ahead and put a coefficient by the oxygen there. Now what will happen often, especially with these types of problems, is that you're going to see that you're going to need to balance it multiple times in order to get the numbers right, and that's perfectly fine. Then you would go ahead and condense down, and then this answer right here will end up being your final product here. So notice a couple of things I want you to notice is that we did not end up changing any of the coefficients, so all of our coefficients stayed the same. The only thing that we ended up changing was our subscripts stayed the same. Our coefficients changed. So the coefficients can change, but our subscripts are always going to remain the same. Okay. At this moment, this will close out the instruction portion for this lecture, and then we're going to go ahead and have some practice that we can go ahead and work on these, and then we'll get a couple easy ones to get you going, some medium ones, and then I'll even throw in a couple of hard ones for you. All right, until I see you next, have a good one.